My name is Spandan. I joined MadeSafe towards the end of 2014. So those were the days when MadeSafe was in like C++. So saw that transition over to Rust. I have my commits pretty much in most of MadeSafe libraries. So I've coded SafePlan libs from scratch, probably Rust from scratch, quite a bit in routing as well. So currently I'm just I'm a backend systems manager, so part of my job is to hire people like Pierre, who are smart enough to produce Parsec. So that's where I am.
Cool. So given that we're kind of focusing on Crust, we should start with that. But I think before we do, there's probably some people, well, I think there are some people in the room who are very, very new to what the Safe Network is and what it represents. So I think it's almost an impossible question, but I think it's one that we have to keep asking because everyone has a different view. How do you describe the Safe Network? What the technology is, or what it represents? However you usually say to on the few occasions that you stop coding and go into the real world, when you have a chance, how do you explain it?
So the main thing is it's decentralized, right? So currently the internet is centralized as you go to some organization to store your stuff. So decentralization sort of takes that control away from organizations and it distributes to people. So that is what Safe Network is about. But the unique thing is there is data involved as well in this case, and it's one of the first, I guess it's the first decentralized internet where you will be allowed to log in, create an account. So that is what Safe Network is.
Cool, and there's loads of that around self-authentication and all sorts of other things that we're not going to touch on here because I mean we can go into that in questions or in the pub, probably more likely afterwards for anybody that's really interested. But we're going to focus on Crust tonight. We're throwing this term out there. Crust, it actually stands for something. And
yes.
I'll let you explain what it stands for.
It's connections in Rust, so it's just an abbreviation for connections in Rust. So because we use Rust as our coding language. So.
And I always, let's bring it right down to basics. So if we think about what is Crust, if you've got one sentence or two sentences, the first question is, what is Crust? And the second one is, why is it essential?
So Crust is the IP transport layer, and it is essential because the way the internet has shaped up, internet protocol is the most base layer protocol that you need to work with. So in order to communicate with people, MadeSafe sort of develops its own network over the internet layer, right? So that we call an overlay network. But you require a base level protocol to sort of connect, and currently the world runs on internet protocol. So Crust takes the internet protocol and makes sure that you are connected in a peer-to-peer fashion.
Cool. So from my perspective, I always think of it as being Crust as like the railroad tracks, whereby computers are able to share information and connect directly with each other around the world.
Yes.
That's as one way of looking at it. But when it comes to connection, people that aren't in with the weeds of networking and thinking about these things on a daily basis, I think a lot of people maybe aren't au fait with some of the challenges that you get when you're trying to connect two computers together. So I wondered, could we just go into what those problems are, how you see those problems and how Crust solves that?
Okay. If at any point if it goes too technical, just give me just tell me right now. Sure. I'll try to make it like a little less technical. So the main problem is in a centralized world, you have something called a server and you connect to a server, right? And all these servers are basically public-facing IPs. What that basically means is, say you type a query in Google and it goes to a Google server. There's a DNS resolution, it finds some IP endpoint and it goes to Google. Now, if you want to decentralize it, not everyone will be public-facing, as you would recognize, like most of you guys probably are in your house behind a router. So you use a router to communicate to the external world. That router probably is also provided by your ISP. These routers shield you from the outside world itself, because the outside part we say is public. And the part behind the router is private. So unless there is a communication, you can see it as a watchman, right? So it prevents people from coming into your house unless you tell the watchman that I want this person to come to my house. So the way you do it is you first communicate to an external world, say a Google server, and then Google server can reach back to you. But it cannot reach back to you unsolicited. Like if you don't communicate with Google, it cannot just come to your computer and give you information. So the part of the challenge in the decentralized world is you need a peer-to-peer communication. There is no server that's involved. So in that case, you are behind a router in your house and somebody else is behind a router in their house, and you guys need to connect to each other in order to form the network. So that's part of the challenge.
Okay, so when we're talking about this issue, because I think we all understand that on a basic level, however technical we are, we have computers that other people can't access, and that's generally a good thing. In this case, it's a bad thing because we want this direct connection. So let's talk about some of these things. Let's talk about internet gateway. Well, basically the different things: the NAT traversal, IGD, hole punching generally. Do you want to? I don't want to lead you on that. Like, if you can explain it in the way that you think is clearest, please.
All right. So any technique that involves tricking your router in order to connect to another peer is called NAT traversal, right? Because routers basically are NAT devices. They do some sort of translation, network address translation, that NAT stands for. So if you pierce through them, that's called NAT traversal. There are various techniques that you can use. The simplest way, you can just go to the router and manually forward a port, right? You can say that, say port 5000 is now public. So anybody who knows my external IP and port 5000 can connect to me if I have a listener or a server running on my local machine. So that's the simplest way to make yourself public. The other ways to make yourself public. You can ask your internet service provider to provide you a static IP, so that will also be a public one. Normally, when you run Crust or you run any app that uses Crust, say MaidSafe Vault, you don't really want the user to go to the router and then manually forward the port and all that stuff, right? So we try to make it as seamless for the user as possible. And there are routers that support something called UPnP, so that is Universal Plug and Play. So if the routers support UPnP, then we can talk to the router via the software and do the same thing what the user would have otherwise done if the UPnP wasn't there. So there is a protocol called IGD, which is Internet Gateway Device Protocol. So via that, you tell the router, hey router, can you forward this port for me? And if the router says yes, then you basically have that port forwarded. So that's another technique of getting yourself publicly available. These things though come at a price, right? Because when you forward a port, it basically means that you are publicly available on that port for everyone. What if you don't want that? What if you just want to connect to one peer? Well, you can alter your firewall tables and all that stuff, but those are manual work. What shines in this area is something called hole punching. And hole punching is, again, the third NAT traversal technique, in which you do some complicated stuff to make sure that you're the only one connected to the peer is the only one connected to you on that particular open. So what the hole is basically you are creating a hole in the router and tunneling through it. So that's why the name hole punching.
Yeah, I think it's quite an evocative name as well, because what we're actually doing is creating something with incredible security, but still getting through these layers that are kind of obfuscating computers. So there's all sorts of interesting things around the implications of this, but I think probably the obvious thing to go on to is, with this sort of technology, it's been developed in terms of the Crust library, in terms of the work on there. A lot of that work's been going on for how long now?
How long since Alpha 2, you mean?
Well, I mean, just in terms of what we released in terms of the test, how much work has gone into specifically what we were testing there. I mean, it's a fairly chunky piece of work.
Yeah, it's probably a year's worth of work right now.
And leading up to that, we got to the stage of testing it. And
yes.
The exciting thing was, because it had never been out in the wild before, so this is why I think we internally we're so excited about it, because you can spend a lot of time thinking, planning, building, but until it goes out, you don't know what's going to happen. So
yeah, that's one thing with networking, right? Because it's impossible to say that the thing works and is robust until you test it in the wild. That is networking, right? So we are lucky to have kind of a community that helps us do this and gets a very wide audience. And because it involves networking, geographical distribution helps a lot because you get different router kinds in different countries. UK routers are one of the friendliest routers, and the routers in the eastern hemisphere probably are pretty restrictive. So you come to know of various router behaviors and various firewall behaviors and ISP behaviors. So it's nice to get like a wide sample.
So a few weeks ago, what we did is we released the software. The software, as with everything, is all open source, so it's all on GitHub. People can download it and play around with it. We released what was the first test. Can you talk us through that in terms of what we were trying to check worked, and then maybe what didn't work? And yeah, we'll start with that.
The first test. So the first test was our first shot at this one. We had the library and we had integrated that library partially into Cross, and now we wanted to test how good our NAT traversal technique is. We did test it internally, and we did test it with a few people, made safe staffs themselves, lodged in various countries. But the taste of the pudding basically is when you actually give it out to the community and you get a wide audience. Once we did that, the results were pretty impressive, because we were thinking it's not going to be that good and we need to tweak it a lot, because that was the first test, right, in the wild. But what we received, what we got as results were pretty impressive. So the things that we thought we need to tweak and make it work, sort of all our assumptions basically paid off at that point. There were a few things like maybe routers in China that were very hostile to NAT traversal. So success rate over there was very miserable in the first test. So we learned something from that, and then we analyzed the data and then tried to tweak more parameters and get other things, other techniques of NAT traversal into the code and launch V2.
Yeah. And so at that stage then we moved to V2, as you say, and that ran for a little bit longer actually this time, I think, looking back
yes.
at it. So overall,
did you sort the issues in China then? So you said that they were hostile. Did version 2 sort it out?
Spoiler alert. Spoiler alert.
Wait for the presentation.
Sorry, apologies.
No. So Spandan, do you want to take that one?
I could hear the question.
Oh, okay. So the question was just about did we fix the issues that we saw in China in terms of some of the connection?
Oh yes, we did. That's why V2. Yes, we did.
Yeah. So V2 basically. We managed to see that, and in terms of like the engagement across the community, because from my perspective as well as everybody else's, but particularly speaking to a lot of people in the community, that was a really exciting thing as well for me, who's maybe slightly further back from the actual sheer technology of it. Because how many unique connections was that again? It was about something like 11,000 odd, roughly.
Yes.
12,000.
11,000, yes.
Okay, and countries around the world.
It's more than 25, I guess.
Yes. So I mean, it was fairly well distributed. There was obviously lots of different people doing it in different places around the world, and everybody got a dashboard to be able to play around with and look at their own results, didn't they?
Yeah, and there was a slight concern in the forum that many people might have used VPNs, so we might have ended up testing the VPN routers more. So, say you are in Belgium, right? And if you use a VPN that goes via, say, Singapore, and if everybody uses sort of the same kind of a VPN, then we are actually testing routers in Singapore that belong to the VPN, right? So it's not that geographically distributed. So we did run a poll, and it seems it's good to know that the VPN users were really minority, and most of the VPN users also ran it without the VPN. So we actually tested the ISP routers that people use.
Yeah. So that's kind of the test in a nutshell, I think. I mean, there's obviously far more layers of technical detail we can go into. I'm not the person to lead that, but if anybody has questions about that, then let's go down that route. But I think hopefully that gives everybody a very top level view of what Crust is, why we have it, why it's been developed. It's a way of connecting computers around the world whilst we're building this decentralized network. We need to have that ability to get through firewalls, to get through kind of routers that might be in the way. We need to ensure that people can basically run the software from home and be able to be part of this new decentralized autonomous data and communications network. So that's all great, but Spandan, what's your next trick? What have you got up your sleeve? What's coming in the future? Are we expecting more tests? Are we happy with the results we've got?
The results have been impressive so far, so we are happy with the results, and we also need to understand why connectivity is that important, right? Because you can argue that if I cannot connect to you, then why not use a relay, and then we can connect via relay. So there are tons of other things that we can also do. It all ties into securing routing, because after all, after everything being said and done, routing is the brain of MaidSafe, right? So Crust exists in order to make routing's life easy. And if you don't connect directly to people, then you will need to find tunnels and relays. That introduces a lot of complications in routing with regards to malice handling and other things that just fall into this eventual consistency problem. So that's why connections are important. Once you have this connectivity, the next thing which is important is security, right? So the security aspect of Crust comes through encryption. So everything that we put on the wire, we encrypt it. So this is what we call secure serialization. There is nothing that is not encrypted. In fact, the V1 test that we ran did not have encryption enabled because that wasn't the point of the test. The point of the test was to see NAT traversal. And we did see some aberrations over there, right? So routers basically can pick up certain parts of your payload and can change them at their whim. So that might be like some misconfiguration of the router, or maybe somebody is doing it deliberately, maybe some intermediary doing it deliberately, but whatever it is, we did see our payload getting mangled, which is not a good thing. So if you transport something over TCP, say, and your payload gets mangled, it should raise some eyebrows, right? The only way to prevent that is by encrypting the data. Once you encrypt it, it's unrecognizable by anybody but the destination. So they don't have any interest in tinkering with it. And they cannot tinker with it. And if they do tinker with it, then there's a guarantee that it will be detected at the other end that the data has been tampered with. Whereas that is not the case if the encryption is not involved. So the next step is having the secure serialization put into Crust. One more interesting thing is bootstrap cache, which is not there in Crust right now. And what that would mean is, say, how do you connect to the safe network, right? So you need some initial nodes to know. So that we call them hard-coded contacts. So they come with your config files. So you know that if I switch on my computer and need to connect to some nodes, you need some fixed set of nodes to at least find the network. But if they are the only set of nodes that are helping you to connect to the network, people can be lost, right? So they can be taken over, they can be taken down, and then you no longer have people to connect to. So bootstrap cache is sort of, once you connect to the network, you keep discovering the network, and that is because of the routing, the way routing works. And this one section that keeps discovering new people, keeps adding new people, and nodes get relocated into newer sections or other sections. When they get relocated to different sections, they discover newer nodes. And then Crust starts prodding whether those nodes are directly reachable or not. And once it confirms that they are, it'll store them in the cache. So next time if the node goes offline and comes back online, it does not depend on the hard-coded contacts that we initially gave it, right? So you can just forget about that and use the harnessed bootstrap cache in order to connect people. So that is very important as well, because otherwise governments and countries can just go and say that, okay, there are probably 1,000 nodes that help people bootstrap to a safe network. Let's all DDoS those 1,000 nodes and bring them down, and then you no longer have a network. You'll still have a network, but new nodes won't be able to join because you have basically taken away the entry point. So bootstrap cache is very important to prevent all that. So these are some of the things that are going to happen across the future.
Yeah, so I think, I mean, the takeaway from this then, just kind of wrapping up, is for this one, it's trust. Trust is the way that computers can speak to each other. Things like encryption are utterly essential, and also the ability to ensure that nodes can contact and identify new nodes to join and leave the network, to join the networks rather, is crucial as well for kind of resiliency, because at every stage we've got to make sure that everything's secure, everything's encrypted, and it doesn't have these central points of failure in effect, or just a list of people that others can attack. So, okay, cool. I think that's kind of covered everything that I had in my head on my list to go through in terms of cross. I don't know if there's anything else you want to mention, Spandan, or whether we just open up to questions.
There are a lot of other things as well, like it uses multi-protocol, so it doesn't just confine itself to one protocol. And it's a random port, which is also of primary importance. Cross nodes just come up randomly on random ports. Why that is important is, say like if MadeSafe always came up on port X, right, 5,000 or something, then first of all you can easily identify if people are using port 5,000 or not. Probably everything is encrypted, but you can sort of guesstimate that might be a MadeSafe traffic, right, because it's using 5,000 ports, so let's ban port 5,000 or something like that, or let's interfere with data. So it's essential that we come up with random ports every time, and that's part of the challenge, because if you come up with a random port, if you don't have a fixed port to go to, how do people discover you? So all those things are like challenges of crosstalk. They're pretty much figured out, just a matter of putting them in code.
So what if you open the network, or the node tries to open a port that's already in use? What happens?
If the port is already in use?
Yeah.
When you find that random port, generally the operating system will allocate a port to you which is not already in use.
Right.
So,
okay. But how does the operating system know that the router is not using that port? So you need to go through the router to open the port, right?
yes. So once you have a port on your local machine, you can ask the router to do one-to-one mapping. If the router fails to do one-to-one mapping, then you have fallback strategies, right?
So
use the next port, or use some sort of a port prediction. That library P2P that Crust uses to do NAT traversal sort of goes through certain logics to kind of predict the port in those cases. So it also ties into what kind of NATs you have. So you have different kinds of NATs. So there's a NAT called symmetric NAT, in which if I connect to you from the same port, it will allocate me, say, port X on router. If I connect to somebody else, again from the same port on my local machine, it won't allocate X anymore, it will allocate like X plus 2 or something like that. So again, you need to predict that if I connect with a third person, it's probably going to be X plus 4. So there will be a port prediction.
It will keep trying if there's a failed connection, right?
Sorry.
Sorry, I don't think you heard what you were saying.
And now I say we'll keep trying if there's a failed connection. So
yeah. We make some guesses, just some heuristics. If everything fails, then obviously it fails, and we just restart the program. But that's the robustness that Cross needs to code itself.
How is this project so far being funded?
How's this project so far being funded?
Yes.
All right. As far as my knowledge goes, I think it's crowdfunding, and most of it is crowdfunding, I guess. People believe in it, and hence they invest in the vision and the mission and the stuff.
So there was crowdfunding back in 2014, and there was equity funding in the company again back in 2016, possibly. I can't remember.
So how would those people get a return? How would the equity people get a return on their investment?
In the same way, because Meetup is a company that's carrying out core development on the project, but the project is open source, obviously. So ultimately, whatever is created will need to have people around the world working on it to scale. So once the project goes live, there's a number of things that we could do. In some ways, I always think about it as being Meetup is trying to put itself out of business, which isn't technically correct, but what we're trying to do is get the network up so it's out, it's live, people can use it. And then there's all sorts of different things that people who've been working on the network will be able to do, such as build applications on it, and there's a model whereby pay the developer developer effectively. So somebody who creates an application can have a direct revenue stream. So if somebody is downloading your application and using it the whole time, then because of the nature of the currency, effectively Safecoin, which is the currency that will be on the network, then they can be paid directly without having to go through an intermediary to run that. So we'll have people that need to work on kind of core tech in terms of upgrades and everything else, along with everybody else in the world. But that will come down to who's building the best tech to be able to service the needs that there are at that point in time.
So how does SafeNet, the company, fit in with the decentralized internet, the idea? And like you said, what is the risk that SafeNet gets put out of business and this is a great success and everyone's happy, but SafeNet becomes worth nothing?
Made Safe? So if Made Safe, the company, goes under...
No, that's why they go under.
Well,
what happens if the idea is so successful that everything's achieved without the need for this company?
Then we've all won.
Yeah, kind of.
Basically,
Except
it's kind of
capitalist.
without being flippant about it. Yeah, absolutely. But I think everybody that has invested in what's happening here is invested in the idea of a decentralized internet, etc. So it is, it's a weird model from a normal historical. You kind of fund a startup, get 10x return, and walk away. I think if you ever have a conversation with David in particular, and the founder, it's not a project to walk away from, and I think we can see that in the community as well. Hopefully, that will continue to grow over time. But people are doing this because they kind of believe in the goal as well.
May I ask a question about routing and Crust? So if my memory serves me from a long time ago, I studied the basic routing protocols of the internet, and there is a decentralization to the basic level of the internet, whereby if machine A wants to talk to machine B on the other side of the world, it will find a kind of optimum route through all the routers to get to it, and it will assign some kind of weighting or cost to that route. And if halfway down that route something goes down, then it will find the next most cheap route that it can take, and the A and B will probably never know that something happened in the middle. So there's this kind of rerouting effect that happens dynamically. Is there any relevance of that to the crust layer? Is there some similar mechanism going on there? Or is it more focused on the hole-punching public-private bridge?
Yeah, so that's a very interesting question. When we talk about message delivery in a safe network, we should note one thing, that the delivery happens on the overlay layer, right? That's not at the cross layer. Cross layer is only concerned about direct peer-to-peer connection. The overlay layer, which is the safe network layer, that doesn't care the bottom layer is crossed. It just happens to be crossed because it happens to be IP and so on, right? There's another talk of mine where I said that instead of internet protocol, it could have very well have been like ATM that took over the asynchronous transfer module instead of internet protocol. So then it would be that. But MadeSafe doesn't, the safe layer network doesn't care about that part. What it cares about is the overlay part, which is routing. And routing has all that ability, which you just said. So we call that disjoint route because we have disjoint sections. What that basically means is once a section reaches a critical mass, it sort of breaks into two, splits into two, and then they split into two, and they split into two, and so on and so forth. That's how the network grows. So it's like a binary tree. And soon you will realize that not everybody knows everybody, right? Because if everybody knew everybody, then what was even the point of splitting it then, right? It could just be like a big blob, just like what blockchain is, and that's not very scalable. So once not everyone knows everyone, and if you want to deliver a message from one part of the network to another, what happens? You go via hops, and those hops are intermediate sections, and that's where malice, and that's when malice detection, and what happens if nodes are not behaving properly, group consensus, all those things kick in. And we have something called disjoint routes, and those disjoint routes take care of the exact scenario that you're saying, that you choose a route for the destination, and as you converge to the destination, people know more and more about the destination. So if a route fails, then you go to the next route and the next route and the next route and so on and so forth.
Thank you. Interesting.
Yeah, and the way it works is the mathematics is like proven by Kennedy, I guess. So if you're interested, then the way it works is like a section needs only to know other section as neighbors and connect to them if it differs in 1 bit position and the prefix length of it. So if the prefix length is like 5, so you have 1, 1, 1, 1, 1, something like that. If there is a section which is 1, 1, 0, 1, 1, 1, 1, 1, then you connect to it. But if there is a section that is like 1, 1, 0, 0, so it basically differs to a 2 bit position, then you don't connect to it. And then what happens is, with that being given, you can basically route from any section to any section. So that's covered by the mathematics.
That makes sense. Okay, so Crust itself is really, as you were saying, is the peer-to-peer part, and that's why there's such an emphasis on this NAT traversal and hole punching.
Exactly, because the invariant in routing right now says that in a section, every node should be connected to every other node, and in the neighbor, because I said like a section knows a certain number of sections around it, so it should be connected to every node in those neighbors as well. So if Crust is unable to provide a connection over there, then routing, the invariant says we have to connect, right? Otherwise the invariant breaks. So the routing has to find a tunnel. It needs to find some other node which is connected to both the nodes and stuff, and that complicates routing a lot. So to prevent that, Crust needs to be as robust as possible to sort of make that connection whenever routing dictates or whenever it tells it to make a connection.
Any other questions on Crust at all at this point in time?
What more on the network? I could be all day. There might be some for the pub though, but I'll ask it because it's online.
Sure.
So I've got a couple, right? The first one is, if you've got applications in a current set at the moment that use current technologies and frameworks, like for example, if you've got AngularJS web apps and you've got .NET Core microservices and you've got a database, and you want to recreate those on the safe network, how easy is it to migrate it over to the safe network? So think of it as a business, right? They still want to keep running, but they like the benefits that your network provides. How easy is it to migrate their applications onto your network? Is it simple? It's just data, we can just poll it over or push it over? Because I guess in the database it's going to be quite complex, right?
Yeah, there will be some paradigm shifts, right? So it won't be like, because safe network is very different from ClearNet in that most of the operations currently are client side. So we have demoed that we can create a browser that is available specifically for safe network, understands safe protocol. We did create the email app, so that is a very bare bones email app. So we create products, not to launch them as made safe products, but just to give a demo to the app developers to just show that you can develop all these things on safe network, right? So the email app works, so the inbox and all those things work, but they work in a slightly different manner because we don't have a centralized server. So currently when you write a mail, it goes to the server decides where to go, who to go to, push notifications and all that stuff. In case of safe network, the paradigm shift is more or less things need to be done client side because the vaults currently are, they don't interfere with your data. They can only interfere with your data if the data is public. But if the data is private, there is no way vaults can interfere with that, right? Because they don't even know what the content is. So in that case, you need to fetch it to the client side, decrypt it, and do something. In case of a server-based model like the current net, your keys and everything is with the server, right? So if the server people want, they can basically snoop on your data. There are so many iCloud leaks and stuff because of that, because it's not client-side encryption. In safe network, it's completely a client-side encryption, so there's a paradigm shift. But I think there will be a one-to-one mapping. Like I need to see case-by-case basis, but mostly anything that you can do on ClearNet, you probably can do on SafeNet.
Okay.
Can I add something to that?
Please.
So, like, if you want to port, say, a web app that exists currently, it probably has tons of dependencies on the ClearNet. And from the safe network, you can't just like bridge to the ClearNet because, like you're told, your data will be secure, and so we don't want for you to be redirected to the ClearNet without noticing. So you're gonna have to migrate all of it, so that can be complicated, but one thing we're looking at as well is looking at internet standards, like future internet standards, like RDF and linked data, which is what Solid uses. And so as the web migrates to these kind of standards, then you'll be able to actually just port from the ClearNet to the safe network because they will speak the same language. So kind of in the future, this is going to become easier.
Okay, alright. But right now, you can't just, I mean, it's not negative, but it's just an understanding of where you're at the moment, right? You just can't bung a...
Because right now, I don't even think like RDS is that, sorry, it is becoming popular, but it's not like it's dominating either, right? So currently they're lax.
If you take the data store out of it, because I know you get involved for that, but so if you were to build a web app, do you still have HTML? Do you still have, so those types of technologies that all developers are familiar with at the moment, do you have that as your application, your API? Can you create a HTML web page, load it up to your safe network, and have people request it via your browser?
Oh yes, that part is extremely easy. Okay. So that's already done. That was done, I guess, in Alpha 1 itself. So you create like the web apps, they come to your browser locally, they run on your browser, do some query, put it up to the safe network again. So the browser, basically, the safe browser does exactly that, right? So that part is completely done.
Okay. So my last question, so then everyone goes to the pub, and well, got to get my money's worth. What's the biggest threat to your network at the moment? And this is an open-ended question. It's probably a question for Pierre in the pub. Like, for example, I would say that you've got multiple nodes in a network. What stops people from uploading a virus to infect all of your nodes? I know you've got security built in, security by design, but that's just an example. What do you think is the biggest threat? This is for everybody that works with it. Apart from apathy.
Right, so there might be technical. So we are still evolving, right? So there are some unresolved questions and stuff. So network segmentation could be one, but we do know that if we implement our consensus algorithms correctly and everything around it correctly, that we can recover from network segmentation once those segments kind of find each other again, or the segments can just continue in parallel, and then when they find each other, then we need to decide which one to take care of or which one to discard, because each can have data by itself, right? So those are like a few challenging areas. Updates are extremely challenging. How do you update things in a decentralized internet? Say you want to release a new vault or something like that, an improved code. How do you not break the existing data which is stored? Because there are no servers. You cannot just go to a centralized authority and say like, okay, do something, encrypt everything and re-encrypt, but put it in this format. We can't do that, right? It's user data, we can't even read it. That is another one. There will be few, theoretically, like if everything collapses, then of course you have problems like meteor hitting on Earth. You have everything, but yeah, practically probably these will be the things. Because why I'm saying that is the consensus depends on a certain number of people acting good, right? That is what consensus means. It comes from the very fact that if you take a bunch of human beings, a majority of them are going to be non-malicious, is what we are saying, basically. If majority turn out to be malicious, then there's nothing we can do, then everybody can break the system. But then there are various de-incentivizing factors for that. We have node aging, we have the currency, the cryptocurrency, Safecoin. So those will affect all these things enormously. They'll de-incentivize you from acting malicious because there's more to lose than to gain.
What's the bit now?
Cool. Is any more questions or move on to Pierre's? Okay, cool, great. Well, thanks, Spandan. Thanks for doing that.
Thank you.